Okay, so what we're going to do here is we're going to derive our resistors in series formula. Now, if this comes up in the exam, this circuit will probably be given to you. We're going to label it with a few important terms. Okay, so first of all, we're going to label that this is the EMF. So it's you could say it's the voltage of the cell, or it's better defined as the energy per unit charge provided by the supply. In this case, it's a cell. We're going to add on V1, V2, and V3, which is the voltage across each one of our resistors. And this question wants us to start with that energy is conserved. So that's what we're going to write first. The energy is conserved. Okay. Now what does that mean in terms of this circuit? Well, we know that the EMF is the energy per unit charge delivered to the circuit, and the voltage here would be the energy per unit charge used up in our resistor. So what we can say is the energy per unit charge delivered to the circuit is equal to the energy per unit charge used here, plus here, plus here. And we get the formula, the energy per unit charge, the EMF, is equal to V1 plus V2 plus V3. Okay, our next step is to substitute in a formula for voltage. And our favourite formula is V equals IR, which is Ohm's law. And for the EMF, it's the same formula. We just write it slightly different. We write the EMF is equal to the current through the cell times the total resistance. We're going to substitute these into this formula, and we're going to end up with the current through the cell times the total resistance equals the current through resistor 1 times the resistance of resistor 1 plus the current through resistor 2 times the resistance of resistor 2 plus the current through resistor 3 times the resistance of resistor 3. Now this is a series circuit, so we should know that the current through our cell here is equal to the current through our resistor 3, resistor 2 and resistor 1. The rule is, in a series circuit, the current is the same at all points. So we should write that down. In a series circuit, the current is the same at all points. Okay, and that leads us to that this current here, the current through the cell, is equal to I1, which is also equal to I2, which is also equal to I3. And that's nice because that means we can cancel out all of our currents here, and we're left with the formula, the total resistance is equal to resistance 1 plus resistance 2 plus resistance 3. And this is our resistors in series formula. So again, this is another one you just have to memorize. It's easy marks in the exam. You just need to practice writing out step by step. Use the video to help you, and I'll see you in the next one.